Okay, guys, if you just look, transversals make their world go round. Oh, yeah. All right, so if you take a look, what we're going to talk about today is we're going to talk about how we're going to use the angles formed by those transversals that we talked about in 3.2 to prove that two lines are going to be parallel. So I want you to think real quick, how am I going to be able to do that? Well, it all is based around the fact that these angles are going to be congruent. You know, when we talked about in the last section that when two lines are parallel, then cut by transversal, we know that these angles that are there, like alternate interior, alternate exterior, corresponding, all those are congruent, right? And same side are supplementary. But what happens if I want to prove that the lines are parallel? Well, then we have to take a look at something else. So what we're going to start with is we're going to start looking at two lines. And if you remember from 3.2 section, these lines are not parallel unless I have the little arrow mark. And if you remember from 3.2, everything started with these angles. If the lines are parallel, then these angles have specific properties that go with them. What you have to remember is that it all comes back to the corresponding angles postulate that stated that if two lines, L and M, are cut by a transversal, and these two lines are parallel, then the corresponding angles are congruent. But now, since I don't really know that these are parallel, I have to use the angles to look and see if they are parallel. It's like going backwards. And when we go backwards, that's called the converse. So we're going to look at the converse of the corresponding angles postulate. The converse of the corresponding angles postulate is pretty simple. If we have two lines that are cut by a transversal, okay, and they're parallel, then the corresponding angles are congruent. That's the corresponding angles postulate. However, if the corresponding angles are congruent when they're cut by when the two lines that are supposedly parallel are cut by a transversal, then those lines are going to be parallel. So let me read that book definition for you, just because I hate the book definition. Let me just read it to you. Okay, it says, if two coplanar lines are cut by a transversal so that a pair of corresponding angles are congruent, then the two lines are parallel. So basically, these two lines are going to be cut by the transversal. Since the two lines are cut by the transversal, and if I was to say that angle 1, which is corresponding to angle 5, is congruent, then that means that this line L is parallel to M. So that's how we are going to prove that these lines are parallel. We're going to use, instead of the corresponding angles postulate, we're going to use the converse of it. So let me give you an example, okay? So if we're going to use the converse of the corresponding angles postulate and the given information to show that L is parallel to M, what we're given is that we're given that the angle 4 is congruent to angle 8. If you look, angle 4 is congruent to angle 8. You need to make sure that the angles are congruent. Okay, measurements do not matter. Okay, if you say measurements are equal, you have to show that the angles are congruent. Okay, I'll show you and I'll explain to you in a second. Since these angles are congruent, I'm allowed to go straight to saying L is parallel to M. Why? Well, these guys are corresponding, and if they're congruent, then that means these lines have to be parallel through the converse of the corresponding angles postulate. You may ask, do you have to write this every time? Yes, you have to write it like this every time because this is proving your point. You have to show how this is related. All right, guys, it's kind of the same idea, except this is so easy that they give you X. All you do is you have to plug it in to show and verify that the angles are congruent. Right now, we're checking to see if 3 and 7 are going to be congruent. That's what we're trying to show. We want to show that this is congruent to this so that I can show this is parallel to this, L and M. So what we're going to do is we're going to first show that the measurements are equal. In order to show that the measurements are equal, I got to plug 30 in. Okay? So we're going to just plug 30 in and get some answers out. So when you plug 30 in, you notice when you take 30 times 4, you get 120. You subtract that from 80, you get 40. And so you want to show then that this is 40. So you plug 30 in, you get 90 minus 50, which is 40. So 40 is equal to 40, right? So this is how you're going to write these. You're going to say, okay, 40 is equal to 40. The measurement of angle 3 equals the measurement of angle 7. Therefore, angle 3 is congruent to angle 7. Okay, if you recall, this is substitution. This is the definition of congruent angles, right? This is substitution because you're plugging it in. And then finally, since these two angles are congruent, you can say that L is parallel to M because of the converse of the corresponding angles post or postulate. Okay, I want to talk about the parallel postulate real quick. If you just look here, it says through a point P, not on line L, there is exactly one line parallel to L. Basically, all this means is that if I have a line, could be squiggly, I hope it's very straight, but I have a point anywhere in space that's not on this line, we call it point P, that there's only one way to draw a line that's going to be parallel to it. Only one way, exactly one way. So that's what that postulate means. Now, just real quick, I want to talk about this. I'm not going to go over this real in depth, but you can read it for yourself. What I wanted to talk about was that since we have the corresponding angles postulate, and we have the converse of that, we also have the converse of all the other ones. The alternate interior angle theorem, the alternate exterior angle theorem, the same side interior angles theorem, and also that postulate from before. So the idea is that everything comes from that postulate, which makes them all theorems, okay? You need to remember that. They're theorems. The only postulate one is the corresponding angles one. Okay, so we're going to do the same thing. We're going to try to show that R is parallel to S. Right now we know that 4 is congruent to 8, so I can put those marks there. If you notice, these two angles are alternate exterior angles. So since the angles are congruent, I can automatically say that R is parallel to S because of the converse of the alternate exterior angle theorem. You have to be careful. You have to make sure you write it all out like that. Okay, so we're going to try to do the same thing. We know X, okay, but before we do anything, we want to identify what types of angles these are. Type does not mean acute, right, or obtuse. Type means alternate exterior, alternate interior, same side, corresponding, something like that. So when I take a look at this, 2 is right here and 3 is right here. If you take a look right now, look at the screen, take a look at it right now. 2 and 3 are not equal to each other. You should know that. If you take a look at that, those are same side interior, which means we want them to be supplement. If they're supplement, that means they equal 180. If they're 180, then I can show that this line is parallel to this line, but not until then. So what I'm going to do is I'm going to plug this 5 in and show that they're supplement. Okay? Okay, so when we plug 5 inside of here and plug it into the 10x, 5 times 10 is 50 plus 8 is 58. So the measurement of angle 2 is 58. We also know that if I plug 5 in to here, that this is going to become 122. You want to check then and see if these two are equal to 180. When you add them, they are, and so this is very informal proof. You're going to say then that R is parallel to S because of the converse of the same side interior angle theorem. Okay, it's the converse that's the key here. Converse. Okay, I want you to try this one. Go ahead and give it a shot. Plug the numbers in, check and see what you got there, see if they're parallel, prove they're parallel. Pause the screen, come back in a second, and we'll discuss it. Okay, so if you take a look at angle 3 and angle 7, angle 3 and angle 7, those are alternate interior angles. Since they're alternate interior angles, they have to be congruent in order for these lines right here to be parallel. It's based on the theorem. So what we're going to do is we're going to check and see by plugging this x in, if they are. The measurement of angle 3 when plugged in is 100. The measurement of angle 7 is also 100. Since the measurements are equal, that means that the angles are going to be congruent. Since the angles are congruent, I can then jump right straight to R is parallel to S. I have to make sure I show that they're congruent, not just equal. They got to be congruent in order to show this. The reason why? Converse alternate interior angle theorem. It's crucial that you understand this. So make sure that you always include that. Okay, so let's wrap up. Proving lines that are parallel. To be able to do that, we have to use some postulates and theorems. The first postulate that we have to make sure we understand is the converse of the corresponding angles postulate. That's how we prove that lines are parallel using corresponding angles. We also have the converse of the alternate exterior angle theorem, the converse of the alternate interior angle theorem, and the converse of the same side interior angle theorem. Make sure you understand which ones have to be congruent and which ones have to be supplementary. It's important. You have to make sure that you show it too. You can't just say it just because you feel like it. Okay, you got to be able to mean it. So make sure you do that. That's about it. Hope you all have a great evening. Come in with any questions you need, and we'll discuss this tomorrow.